heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
All right, good evening and welcome everyone to Mount Washington Observatory's Science in the Mountains lecture series. My name is Brian Fitzgerald, and I'm the Director of Science and Education here at Mount Washington Observatory. Thank you so much for joining us. And to share all about the impacts of climate change across the northeastern United States is Vermont State Climatologist Lesley-Ann Dupigny-Giroux. And she'll be joining us in just a little bit. Thanks again for everyone who is joining us either on Zoom here this evening or on the Facebook live stream. Thanks so much. For those of you who aren't already familiar with Mount Washington Observatory, we are, of course, a private, nonprofit, member-supported organization with a mission to advance the understanding of the forces that create Earth's weather and climate. And we accomplish this mission by operating our summit weather station with around-the-clock weather observation and forecasting, by conducting research projects and product testing, and by conducting educational programs as well. If you have questions for tonight's speaker and you're joining via Zoom, don't forget that you can use the Q&A button that you can find just at the bottom of your toolbar there in the middle of your screen. If you're joining us through Facebook, just keep in mind you're welcome to ask lots of questions there. We won't be able to get to those live during the program this evening, but we will follow up to the best of our ability after the program. We'll be sure to leave some time at the end of the program here to get to as many questions as we can. If you'd like to join us for the connection via Zoom next time, don't forget that you can register over at mountwashington.org/SITM. Alrighty, well, thanks so much again, everyone, for joining this evening. We'll kick things off like we typically do with a quick poll for everyone who is joining via Zoom. So if you're on the Zoom connection right now, you'll see some questions that have popped up for you. Just a handful or 4 questions for you this evening. We're curious where you're joining from tonight. And oh boy, it looks like, unfortunately, some of our questions and our answers didn't make it through. My apologies. We're going to skip right ahead to our trivia questions here because I know we have a lot of people joining from all over, and we'll get right to the trivia here. So number 3, great question from our speaker tonight. What is a backward season? Is it abnormal weather conditions observed relative to, well, what you might expect for that season? Is it when snow falls mostly at one end of a season? Is it when you travel to the Southern Hemisphere? Or is it when you completely skip a season? And then lastly, question here from our speaker this evening, how old do you think the term climate change is? How old is it? 50 years, 10 years, more than 100? And apologies again for the first couple of questions not coming through this evening. We will definitely get that next go round. We are curious, though, whether or not folks have, at least for that second question, whether or not you've registered this year for the Observatory's Seek the Peak fundraiser this year, going on, of course, in July. More than 2 decades old here. And if you haven't already registered, if you want to learn more about the event, want to find ways in which to support the Observatory and join this exceptionally fun community event, Seek the Peak, you can certainly learn more over at seekthepeak.org. All right, I'll give you just a few more moments here to fill out our questions and get your responses in before we move along here and get our answers as well from our speaker tonight. So we'll give it just a few more seconds, and 3, 2, 1. All righty, and we'll share those results. It looks like for the most part, overwhelmingly, everyone thinks that when abnormal conditions are observed relative to what is expected for a season, that's considered a backward season. And then pretty evenly split there in terms of how old you think the term climate change is, be it 50, 10, or more than 100 years old. So anyways, I'll go ahead and stop sharing there. And without further ado, would love to introduce tonight's speaker, Lesley-Ann. I don't know if you can hear me okay, but love to have you join the program and present for all of us this evening.
Thanks a lot, Brian. Good evening, everybody. It is such a pleasure to be here on a sort of chilly Tuesday evening, at least here in the Champlain Valley of Vermont. And I'm really looking forward to doing a deep dive with you all for the next hour-ish or so. So let me go ahead and try to share my screen here. Hopefully that comes up okay. Seeing that okay?
It looks great. Thanks, Lesley-Ann.
Perfect. Thanks, Brian. So yeah, I was waiting to see what the answers to those 2 poll questions are going to be. So we're going to take a deep dive into that. But before we do that, thanks to Brian and the entire Mount Washington Observatory for having me here to be part of the Science in the Mountains series. It's a great opportunity to share a lot of the things that I've been working on or that have been participating in for the last few years or so. And one of them, it's getting a little bit dated now, but it was the 4th National Climate Assessment, which of course was released in November of 2018. And it was my great privilege and an honor to have served as the lead author on that chapter for the Northeast. And so when Brian asked me if I'd be happy to share a lot of the sort of lessons learned or sort of looking below the hood on how did we actually come up with the chapter, that's what we're going to be doing a little bit of today. And then at the very, very end, I'll sort of do a little bit of a teaser for the 5th National Climate Assessment, which officially got going last year, 2021, and which is due to be released next year in 2023. So we'll talk a little bit about the entire National Climate Assessment process. We'll talk about some of those pieces, and then I'll hopefully be able to share some resources with you. That's a great part about being on Zoom, that you can actually just pop stuff into the chat so you can have that at your disposal. So question number 1, what is a backward season? So this is a term that refers to, of course, when conditions are observed to be going in the opposite direction for that particular time of the year. So, you know, for example, you tend to see a lot of snow conditions in the middle of April and on June, like we saw this year. It's not the first time that we've seen this. We've seen this quite a number of years in the recent past here. We see things like killing frosts occurring during the summertime. And a lot of the precursors that allow us to know that we're going into a backward season is these extreme freeze and thaw cycles that we see in the middle of winter, particularly in December and January. And then once we come out of backward season, one of the other things that we tend to notice is that we go into drought conditions. So we've seen that in the last few years. And I don't know if you've noticed the same thing where you are, but somebody turned off the spigot in the last little bit, and we've been getting drying conditions. And that's one of the things we're going to continue to keep our eyes out to see if we go back into precipitation drought. We're still in a hydrologic drought, and then how does that sort of play out for us? And a lot of times during these backward seasons, a lot of the air comes from the northwest towards us here in the North Country. So that's the first question. So the second question was, how old do you think the term climate change is? What was the first time that you think that was used? And as far as I can tell, if you go back and you're looking into the geologic literature, that's when you'll see the term climate change is being used in the 1800s, when folks started to realize that changes in one part of the world were affecting somewhere else. We were seeing the influence of volcanic activity and how that influenced how climates played out in different latitudes in different regions. And now, with that understanding, we can come and sort of put things into context in terms of anthropogenic climate change and how all of those various pieces of climate change and climate variability sort of go together. So if you said over 100 years, that's the one that we were looking for here. So using that sort of 100-year plus sort of time frame, there's a wonderful resource that if you haven't already come across it, it's called the Science Visualization Studio, and it comes from NASA. And what they do is at the end of each year, they create yet another year's worth of animations that show you how temperatures have changed over time, starting in 1880 all the way up until the last current year. So what you're going to be seeing when I play this animation here is it's going to be 5-year jumps. So it'll start off in 1880 to 1884, then it'll go 1885, right? And what they're doing is they're comparing these 5-year intervals to a mean or an average. And that average time frame that they're comparing it to is 1960 to 1991. So every time you see these blue colors on the map here, it means that that part of the world was colder than that average. And every time you see the yellows and the oranges and the reds, that means it was warmer than that average. So I'm going to go ahead and play it. And as you're doing that, you'll see these regions coming in and out, primarily cold conditions, especially in the early part of the 1900s. And then we start getting into warming signals being observed, but still having those cold periods coming in and out, the 60s droughts, the 60s cold periods. And then in 1980, we started to see things predominantly continue to be warm until we had some of the warmest years on record in the last decade.
Lesley-Ann, it looks like we might have lost you there for just a minute. Apologies for that, folks. It looks like Lesley-Ann's connection might have unfortunately gotten dropped just for a second there. That's too bad. We'll see if we get Lesley-Ann to connect up in just a second here to join back on the program. Hopefully all is okay on her end of things. Hey, look at that. No worries. It looks like a little blip in the connection there, right?
Just a little blip there, just as I was getting to the good stuff here.
Well, it was a good thing because I was about 1 second away from doing my best impression of you, and it was not.
Oh no!
It was not going to be very good. So, feel free to jump right back into it if you can. You were, I think, about to start.
Well,
playing.
let me just double check.
I think you're about to start playing the visualization there.
Oh, is that where it disappeared?
Yes.
Ooh. Okay.
Oh no, Lesley-Ann, it's too bad. It looks like we're losing you once again. Well, in the meantime, folks, I am happy to share what Lesley-Ann was about to share here. So I will go ahead and, as I mentioned here, we'll not do Lesley-Ann justice, but this is the visualization I believe that Lesley-Ann was about to get into here from NASA. Taking a look at, again, we're looking at, this is temperature anomaly, or so the difference is either warmer or colder than the normal, but essentially, again, warmer colors for warmer than normal, cooler for colder than normal globally. And we'll take a look through this visualization just briefly while we wait for Lesley-Ann to hopefully rejoin with a stronger connection here. So we can see pretty early on, largely cooler than normal conditions. As we're getting into the 20s, 30s, certainly much more noticeable. Almost a brief cool off again in the 50s, even 60s, 70s, now getting into the 80s. And by the time we're reaching here into the 90s and into the new millennium, really hardly any cooler than normal temperature anomaly. And in particular, perhaps one of the most noticeable, besides the absence of cooler than normal anomaly here, being extremely or much warmer than normal conditions, particularly in the Arctic in particular, being one of the warmest, fastest warming regions as well. Well, we'll see if Lesley-Ann's able to join us once again here and establish a stronger connection, because it looks like she was with us just she's doing just fine before, so you never know what may end up creating an issue with connections there. In the meantime, happy to share some information from Mount Washington Observatory and some conditions live from the summit if folks are curious, and can share some live views as well from our cameras while we wait. And we'll see if we need to come back and have Lesley-Ann join us another time. We can certainly do that. I appreciate everyone's patience on the live stream here. So right now we can take a look at the top of Mount Washington. Lesley-Ann was talking a little bit about, well, some cooler conditions where she is in Vermont at the moment. While it's certainly cooler once again after a string of record-breaking warm days on Mount Washington, breaking daily record maximum temperatures on the summit and also down here in North Conway Village as well on Thursday, Friday, and Saturday of last week, reaching near 60 degrees on the summit of Mount Washington, which is quite exceptional even for the summer months, breaking some records rather easily, particularly on Saturday, even down here in the valley, getting close to almost 90 degrees in the early part of May. Right now on the summit of Mount Washington, we are just below 32 degrees at the moment. Winds are out of the west at 54 miles per hour, gusting to 68 miles per hour in the last 10 minutes, but not quite as windy as it was within the last 24 hours. We see a gust here of 107 miles per hour coming at about 7 p.m. last night, as some of those thunderstorms are starting to roll through the region. If you're in the Northeast last night, probably saw one of your, maybe like up this way, some of your first tastes of thunderstorms for the new summer season. We can take a look at some of the live stream cameras as well. Happy to share that in the meantime while hopefully Lesley-Ann's able to join us once again here. Give you just one moment as we take a look at our live deck cam, and we can take a look at the camera over on Wildcat as well. We are socked in the fog, as you can see, not necessarily the best of views this evening. Foggy conditions with quite a bit of moisture abound, and certainly windy still. Not a lot of snow left on the very tippy top of the summit at the moment. Certainly snow hanging on in the ravines and some more sheltered areas. A few drifts now starting to melt down. Mount Washington Auto Road opened this past weekend as well to travel. They'll be open again this weekend, weather permitting, with travel now open for the first time this year. So looking a little bit more like summer, certainly the last few days, though today, a little more challenging and traditional conditions perhaps for this time of the year. And let's see if we can have get our Wildcat cam going here as well.
Hey, Brian.
Hey, Lesley-Ann, wonderful. How is your connection doing now?
Well, I sincerely hope it's a lot better than it was before.
Here, I'll make you co-host once again, and let's see if we can pick up where you left off.
makes me scared to even try playing that video again.
Well, you're in luck. I was able to pull it up and share it briefly to show what I believe you were about to show, which is, wow, a lot of kind of cooler than normal activity for a while.
Mm-hmm.
Then you start seeing certainly some warm-ups, particularly kind of in the 1930s and onward, maybe a little bit of a leveling off or even a slight return to cooling in almost the 50s, it looked like. And boy, but by the time we hit the 90s and onward, there was very little blue to be found anywhere on the globe.
Absolutely.
And the Arctic in particular.
Oh my goodness, yeah.
Yeah, just a sea of red there. So let's see, you should have, oh, there we go. There's your camera.
Yeah. I switched machines in the hope that this one's a little bit more stable. I have never had that happen before ever. So my apologies to everybody who's watching this as a live stream.
Thankfully we've been doing this. A lot of us have been doing this long enough that yeah, we've don't worry, we've seen this before too. So yeah, it looks like maybe your internet may be slightly compromised.
And I'm just going to make sure it is the correct one here.
Now it looks like it's doing a little better.
Oh, this is the correct one. Okay. Third time's a charm.
I think so. Let's roll the dice.
Okay. Here we go. Well, by now everybody can sing along with these first few slides because you've seen them so many times. And we will definitely skip this one. Okay, so this is where I was chit-chatting. I think I ended up talking to myself at this point because I didn't know I had lost the connectivity that first time around, and was saying the looking at climate change as an entire system so that we're not missing part of some of the moving pieces in terms of whether it's precipitation, whether it's soil moisture, whether it's different types of greenhouse gases and the greenhouse warming potential, whether it's the effects on different ecosystems, the severity of those changes in your cloud patterns and so on. So in looking at things as a system and seeing how all these various pieces fit together, that's what allows you to answer questions like, how can you have warming taking place and having record snowstorms all at the same time? And part of it has to do with the amount of moisture that's in the air as a result of having that much more energy present, and therefore the ability for having storm systems be even larger than they have been in historic record. So in following up on that sort of systems-based approach, one of the things I always like to show as well are the ways that we can look at our changing climate, whether it's these jumps that have been observed in the geologic record, these trend lines which are more familiar to us with things like increasing temperatures. And I think the last few years, especially with the pandemic and all of the conditions that we're seeing playing out as our climate continues to change, is this last one here, where when we have these increases in various variations in variability, whether it's things like heat waves and cold waves or floods and droughts, it's that ability to thrive as a society, to thrive as peoples within these bounds, within these thresholds that we've sort of been used to, accustomed to, evolved within. And when we exceed those thresholds, that's where we run into particular increases in our vulnerability as a species. So the last thing that I like to do in terms of setting up all of this from a background perspective is to really see which of the elements of climate change are we talking about, whether it's the processes, which are the pieces that you see on the left-hand side here in the oranges and the yellows, or is it the impacts, things like changes in phenology or sea level rise or ocean acidification? Or are we looking at the various mitigation or adaptation strategies to address our changing climate? And then when we put those into perspective, then we see where the resources are being shared and who's vulnerable, who's at the table, who do we need to make sure that we're actually caring for as we step through in creating some of these plans and strategies. So let's talk a little bit about the National Climate Assessment as a process. As what happened in fourth National Climate Assessment, and then setting the stage for what's taking place right now, as I said before, in the fifth National Climate Assessment itself. So the National Climate Assessment comes out of the Global Change Research Act, USGCRP Act of 1990, which said that we were to produce an assessment no less than every 4 years. And if you do the math, you'll notice that we've only produced up to this point here 4 since 1990. So we haven't quite met that. For the first time, it was met with the fourth National Climate Assessment. So we were particularly thrilled about that. So that's one piece that's important. The other piece is that the way in which the assessment is put together, it's designed to help to inform policy, but not to be prescriptive. So the language is very, very careful in assessing and saying what research has been done in the last time frame, what do we know that has changed, but not crossing a line of saying you must do this and you have to do that. And so there's a big emphasis on doing this from a regional perspective, because that's where a lot of the impacts and the risks and the adaptation we're seeing taking place on more regional timeframes and spatial scales. And then how do all of those bubble up to the entire national piece in here? So the fourth National Climate Assessment was put out in 2 volumes. The first volume talked about all of the science and the advances in science up until 2017, 2018. And then the second volume talked about all of the risks and impacts and ways in which peoples across the entire US were making adaptations to our changing climate. There were a couple of key things that were new in last National Climate Assessment. Some of it involved new regions so that we could better get a sense of how climate change was playing out on the ground in these various regions. And the other thing that was really, really new is that we started to see the really important use of state climate summaries. And what those are ground level summaries that talk about what climate change looks like in a particular state, so that it could be used by policymakers, by decision makers, by towns, by municipalities in their work in looking at our changing climate. So those are a couple of things that were new since the 2014 third National Climate Assessment. Some other things that were new and that continue today into the fifth National Climate Assessment is this really important appreciation of using economics and economic studies, so that there's a brand new chapter in the fifth National Climate Assessment that is entirely devoted to what do we know about economic conditions and how do those then play out for us in looking at the various strategies for talking about climate change. Another piece that is also now lifted up to its own chapter in the fifth National Climate Assessment is the use of climate change indicators. And those are led by the EPA, the Environmental Protection Agency, which puts together all of the ways that we can look at indicators, whether it is sea level rise or acidification or Lyme disease or other elements of both the biophysical parts of our landscape, but also human health pieces in there. And a third piece was the use of downscale information, because again, this is designed to assist with local decision making. And so to the extent that we go from global climate models down to local downscale products that will allow us to actually see what's taking place across the region. So as a lead author, one of the things that I was asked to do was to help our team think about what is unique in each of the regions. So for the Northeast, some of the things that were unique that had not been covered in the past, we're looking at our cultural heritage, or looking at inland versus coastal, rural versus urban, upland versus lowland regions, the length of time the peoples have been on our landscape here, and then the particular challenges that are put forth when we have to factor in high elevations and complex topography. So NCA 4, as it's called, really made a conscious effort to frame all of the work that was done in terms of who is at risk, what is at risk, what are the iconic parts of our landscape, what are the iconic parts of our cultures, and then what would happen if we reach tipping points. So each chapter, each group of authors really took this risk-based framework in looking to see what do we know, who's vulnerable, which parts of our landscape are vulnerable, and then what are some of the strategies that either have been used or are coming online to help us look at addressing climate change. And so this was not done in a vacuum. There's a lot of really authentic and deep dive public participation. And so all of the green dots that you see on here are a lot of the listening sessions that took place, public engagement sessions that took place both before we started actually putting together a lot of the material, but also during the entire process as it was unfolding, so that we were always in touch with a lot of the case studies, the stories, the lessons learned, the exemplars that were collected and bubbling up, so that we could then bring those to bear in the actual writing of the assessment itself. So though we had a number of those in January of this year, and as we move into the next few phases of this fifth national kind of assessment, please be on the lookout for opportunities to participate and to share your expertise and knowledge with various teams as the process continues to make its way through. So when the assessment first came out, and I was invited in my role as lead author to give a couple of talks, one of the first things I did was to sort of look through and see what are some of the overarching themes that each chapter, there were 10 regional chapters, what were some of those overarching threads of that tapestry? And a couple of things sort of popped up. We all talked about human health. We all talked about honoring Indigenous peoples. We all talked about the need to pay specific attention to rural communities and our livelihoods, the ways in which agricultural productivity is affected by our changing climate, and the ways in which extreme events are having particular impacts on infrastructure and transportation, ecosystem services, how those being affected by changes in temperature, precipitation, and so forth. And for those who lived along the coast, influence of sea level rise, for example, and then the impacts on marine and coastal resources. So in NCA 4, the Northeast chapter, which is chapter 18, there were 5 key messages. And the first one talked about all of the elements that were playing out in our rural regions of the Northeast, and looking at how the seasons were changing, looking at how those then had a domino cascading effect for ecosystems, for different elements of our socioeconomic activities, be it tourism or farming or forestry, and then what that meant for the way in which our livelihoods were changing. So why was there a focus on rural versus urban? We'll get to urban in a sec. Well, a lot of it has to do with the fact that if you did a population density map, it would look something like this, where the largest cities along the coast and most of the inland regions, with the exception of Philly, parts of upstate New York, are places that tended to be more rural in character and rural in nature. And so what are some of those elements of our changing climate in the rural parts of our landscape? And we could look at it from a frost-free or freeze-free perspective, which speaks to growing degree days, which speaks to the influence on agriculture under the various scenarios. So in NCA 4, the 2 scenarios that we used as sort of thresholds were RCP 4.5 as the lower bound, RCP 8.5 as the upper bound, and then what are some of those elements in between, so that you can see things like the changes in the number of days that you would be able to conduct agriculture, for example, in this particular slide here. Also related to those changes in seasonality were when did we have stream flow occurring, especially in the springtime. So this is some work that was done by Glenn Hodgkins and Rob Dudley in looking at those changes in precipitation and looking at the changes in storm flow. So the triangles show you the size of them, shows you the increase as a percentage. And then the fact that they're all pointing upward means that it's an actual increase. So we're looking at both more precipitation, more storm flow over the region from Maine all the way down to the southern parts of New England itself. So those were the changes in seasons and the impacts from a rural perspective. Sticking with that sort of natural environment piece, the second key message talked about what are some of the changes that are occurring along our coastal regions, our coastal resources, our livelihoods, changes that fishers are experiencing, changes in the ocean habitat, and the fact that a lot of the ocean warming is taking place faster off the coast of the Northeast than it is for the rest of the nation itself. And so what does that mean for the ecosystems and the livelihoods in our coastal landscape? And so trying to visualize that both from a people perspective, also from a landscape perspective. This is one of the diagrams that was created to show the influence of sea level rise in terms of ecosystems like marshes and estuaries, but also thinking about it from a more physical built landscape perspective as well. So the third key message sort of played off that rural urban, and it spoke to the fact that in the Northeast, we can't have rural without urban and vice versa. And so that third key message brought in that interconnectedness of the urban regions and also highlighted the particular challenges of our urban places in the Northeast because they've been settled and peopled for so long. And so there's a length of time, there's an aging of infrastructure, there's a significance in terms of some of the sites from a cultural perspective, from a socioeconomic perspective that need to be factored in as we step on through. And so thinking of some of the older cities across the Northeast and looking at ways in which, for example, flooding as a hazard is changing in terms of frequency, in terms of dynamics, how do we sort of factor that in our mitigative strategies? And then one of the case studies was looking at the lessons learned from Hurricane Sandy in 2012 and the way in which proactive adaptation was playing out across parts of New York City, which is what this photo shows here, that a lot of the subways that were flooded during Sandy, one of the proactive measures in the post-Sandy period was to build these elevated grates so that the water didn't rush directly from the street into the subways, and then to have them as multifunctional, multi-purpose, so that they could be both for pedestrians as well as for bicycle use. The fourth key message came out of public engagement. It came out of listening sessions when we heard that we needed to pay more attention to human health across the Northeast. And so this key message talked about what are some of the emerging or emergent threats to human health. And one of our authors is an epidemiologist, and he worked to bring some of his cutting edge research in looking at emergency room visits and hospitalizations as a method for looking at some of these emerging threats, but also thinking about things like air quality and water conditions, Lyme disease, as I mentioned before, and how that sort of played out. So here is some of his work here in looking at some of these elements from ED visits, ER visits, but also thinking about it from a heat perspective and some of these other elements that we can talk about. And then the last key message talked about adaptation and the fact that there were a number of these really, really cutting edge examples of adaptation that even in 2015, 16, 17, 18 were taking place, and which of course have just exploded in the last 3 or 4 years. And so this idea of how are we doing this? What are some of the things that are taking place in one part of the Northeast that could be shared with other parts? it's then some of these exemplars, how do we kind of lift up some of these great examples that we have in here so that we can then take it to the next level in the ways in which we can use some of these exemplars. So all of this work rests on all of the wonderful expertise of the author team for the Northeast for the 4th National Climate Assessment. And so here are my colleagues listed here, lifting up all their voices, lifting up all their expertise. And we also were very, very fortunate to have a number of technical contributors who either assisted with case studies, with mapping, with other elements of showing the ways in which we can actually talk about our changing climate as an entire region. The chapter itself can be found at this particular site. It's still live, it's still active. The citation you will see on here. And I'm going to leave the citation here so that you can copy it down. You can also just Google National Climate Assessment Northeast chapter if you'd like that. If you'd like more information, happy to send that to you. There's my email address in here. And then what I wanted us to sort of close with is this particular diagram, because it's my absolute most favorite diagram in the entire 4th National Climate Assessment, and I'll tell you why. So I've been working on the assessment from the very first one back in 1997, and this diagram is so engaging because what it does is it shows you the temporal aspect of the progress made every time we have a new assessment in place. So on the 3rd National Climate Assessment, which was published in 2014, we were just on the brink of learning about climate change, thinking about how to do an assessment, what are some of the plans that need to be in place, and just starting to do a little bit of adaptation. And then by the 4th National Climate Assessment, we actually had some of these exemplars in here. So the 5th National Climate Assessment is really sort of speaking to a lot of those adaptation pieces that have been in place for the last 4, 5, 6 years. What are the things that the states are doing? What are the things that are emerging across various municipalities, for example? And so, again, it's a great way to sort of kick off this idea of where do we go from here in terms of continuing to understand and to share the expertise and knowledge and lessons learned across the entire region. So with that, I'm actually going to turn it back to you, Brian, for any Q&A that might have popped into the chat in the meantime here, and I will try to regain some of those resources so I can pop them into our chat as we step through.
That would be great. Thank you so much, Lesley-Ann. I appreciate your the hurry up and fix the technical issues, which I know we all enjoy so thoroughly in our virtual landscape these days, especially over the last couple of years. Thank you for hanging with us, and for everyone else who's stayed along as well. I really appreciate it. Like Lesley-Ann was just offering, now's a great time for any sort of questions that have popped up. I know a lot of content that certainly we could get into, but we have Lesley-Ann's expertise here. If you have questions about the assessment process itself, how these things come together, any of the materials or beyond that's been covered this evening, certainly feel free to ask your question using the Q&A button that you'll find at the bottom of your screen there. And let's see, we already have some questions that popped up, and I don't know if you can speak to this. I mean, it's one that actually I probably have to, I don't know how confident I am in my own answering of this, but Barbara asked a question that was spurred by the early time lapse of temperature anomaly globally, noticing that really, really warm Arctic zone. Why is the Arctic changing so much faster than the Antarctic, or even just, I'll ask more generally, why are we seeing these uneven changes globally or even say regionally?
Right. Great question, Barbara. And I think a lot of it has to do with the fact that the Northern Hemisphere is a land-based hemisphere. And so most of the land on Earth is in the Northern Hemisphere. And if you think about the Arctic regions, it's an ocean that's surrounded by land, right? And then Antarctic regions, it's a frozen continent that's surrounded by water. So there's two different dynamics going on there right off the bat, right? Land versus ocean, and then reversed. The other thing is a lot of the warming that's taking place on land in the northern hemisphere is occurring so rapidly that the impact on the ocean is also being affected, so that you're seeing a lot of that loss of sea ice very, very quickly. And then once you've got that loss of sea ice, it's sort of like a positive feedback mechanism. So the sea ice disappears, or when it reappears, it's not as thick as it was the previous year. And then we have changes in how reflective it is, how the albedo is. So it's part of that that's also taking place. And then you're also factoring some of the reasons why the land is heating up so quickly. And part of it has to do with the permafrost, the loss of permafrost. And when you lose permafrost, you're not just losing soil material, you're losing all of the methane that was trapped in the permafrost. And of course, methane is a very powerful greenhouse gas. So again, another positive feedback. And then the last piece in there is a lot of those northern latitudes are also experiencing wildfires. And so wildfires are also going to be producing material into the atmosphere. And it's not just the material, it's the energy, it's all of those pieces in there. So a number of sort of overlapping but distinct reasons why we see such a tremendous warming in the northern hemisphere versus the southern hemisphere.
Excellent. That was a very succinct answer to a rather complex set of relationships, clearly that are going on. I mean, the uneven heating, certainly, or even just uneven movement of energy throughout the Earth's climate system is hard to explain. And with all of those compounding issues, certainly makes the Arctic and even some ocean regions just that susceptible to change, certainly. Lots of great questions that are bubbling up here, including a question from Sandra, who asks, what adaptations can you speak to that have happened between the first assessment and now? And I'm wondering, maybe there's some examples that you can think of, Lesley-Ann, that have popped up since 1997 that have been kind of highlighted as some adaptations that have been covered.
Right. That's another great question. And I think in 1997, we probably did not have as many examples or exemplars, because our understanding, our technology, our toolkit hadn't advanced to that point. But I think one of the ones that I always go back to, because it's such a great example, particularly in the energy space, is the RGGI, the Regional Greenhouse Gas Initiative across all of the Northeast, and the way in which collaboration, shared perspectives, shared resources can help move the needle. And to the extent that region-wide examples like that are critical and important, is because sometimes when you're a smaller state and you're trying to do it by yourself, you can only get so far. But if you join forces and you pool resources and you pool expertise, knowledge, science, and even money, then it moves that just a little bit further. So I think that regional approach is great. But I always like to do this sort of stuff, because it takes both the top down and the bottom up of people on the ground, policies on the ground, meeting with what's taking place either at a state level, at a regional level. So it's not an either or.
Yeah. Well, and even in that example, Lesley-Ann, is that even an example of mitigation as well? So actually trying to mitigate the emission of greenhouse gases that further exacerbate a warming climate and all those sorts of things. And then, so I mean, that's even like a very, very more proactive, bigger picture, top level, like you're talking about. And then even you gave sort of one of the examples that was referenced in New York City with the race subway vents as, I guess, like a very specific, maybe not massive, adaptation, but certainly that's one very concrete example of, how a city or an environment has adapted their environment to change.
Right. And then there's some other examples, some wonderful examples along the coast. I remember as I was at a talk last February, and it was at Salem State. And one of the invited guests was a local nonprofit who was talking about all of the ways that they had raised money to plant grass, like the native grasses along parts of the broad walk and parts of protected areas. And it made such a difference because you were using the local and natural native pieces of the landscape. So it wasn't something that was going to get washed away because it was like human made, right? And so I think those are some, when I saw that, I was like, oh, that's really, really cool, right? Can we replicate this somewhere else? Because it's just one of those that you're like, there's so many wonderful things going on in so many communities across the Northeast and across the entire nation that, an inventory of what's going on is part of what do you do when you start doing this type of stuff, right? Because there's absolutely no need to reinvent the wheel. So if somebody 2 towns over from you is doing something really cool, why not partner or buddy up, right? And sort of see, hey, do you want to share what you did? Or, I was thinking of, and then they can say, well, don't do that. You should talk to this person and sort of like cut to the chase, right? So I think that's one of our strengths as a region, that's sort of like sharing like this. And I think if we play more into that, it'll help us continue to move forward.
Yeah. Oh, that's great. And even spurring some really great questions and thoughts here, I think in that adaptation space as well, where Sean asks a really a thoughtful question about, Sean asks, as we move into adaptation, what are some resources local communities can leverage to identify and explore sources of money to help finance different types of adaptation? So like, for instance, the example you just gave, I mean, down at like Salem State and, coastal Massachusetts, do you have a sense of, what resources they were pulling from, or even from, a local, state, regional, federal perspective where folks can sort of tap into some of these resources that are already available?
Right. So that's a great response to another great question. And it sort of is like a smorgasbord of where do you start, right? And some of these, I think, there's some federal resources, and one that I'll lift up right here is the Climate Resilience Toolkit. It's a, right, you've probably seen that one, Brian. What it brings together are different mitigation, adaptation plans, ways of building resilience at different levels, like from a town level all the way up to a state level. And it has this very clear set of steps that you can go through to figure out what are you vulnerable to, and then how do you try to become more resilient? How do you try to be, how do you try to implement better adaptation, right? So there's that resource. NOAA Regional Climate Service Director Ellen McRae, who you probably know, also is very proactive in being an absolute phenomenal resource for the entire region in dashboards that are available at a state level or at a regional level that are coming through NOAA, but that she also has this ability to bring other federal partners to bear. So that's the federal piece in there, right? I think some communities have actually sort of either carved out money that they put aside in the town budgets or large municipal budgets to assist with this, and I think that's really, it's a really great tool to tap into. Not everybody is that fortunate, and so that's where I think that sort of sharing of resources is critical. But I would say first and foremost, ask to see who else is doing what, right, before you take that deep dive in, because it's an overwhelming dive if you are just trying to do this from scratch. Talk to folks first.
That's great. That's really helpful. Thank you, Lesley-Ann. And I tried briefly, hopefully in the chat there, folks can see it answered that question, at least sharing the Climate Resilience Toolkit, which is certainly a great resource and a great place to start. But I mean, yeah, talk around your town, talk to, chances are other people are thinking about it, acting on it, have connections to some resources here. So yeah, I appreciate those thoughts and that response to that question. Great question here from Ed, who's asking, I guess maybe a little bit about process and response to some of these assessments that have been released. So Ed asks, with a requirement to conduct these assessments with a given frequency, so every 4 years, I believe you said, how are the results or plans acted upon in a timely manner, and how are those actions incorporated into subsequent assessments? And I don't know, maybe this is getting into actual policy and politics or not, because I guess from what I heard you say sort of at the outset is, well, you're sharing policy relevant information. However, you're not making recommendation on policy. So I guess it's really up to the
Right.
politicians to do something or
Yeah.
not, right?
Yeah. So was that Ed you said asked that question?
Yeah.
Yeah. So Ed, that's a great question, and a really I could probably answer it in 2 or 3 different ways, right? So the National Climate Assessment is congressionally mandated, so it has to be done, right? It has to be done, it has to be released. And one of the things that makes the assessment different is that it's a backward look. So you're looking to see how has climate information, understanding, expertise, science improved since the last one. And that's what you're assessing. Assessing progress in science space. You're assessing progress in what do we know about risk, progress in who's doing great stuff. That's what is being assessed, right? And we're bringing it all together into this one place, this one document that has to meet certain standards, including the Information Quality Act, the Evidence Act. It has to be Section 508, so it can be accessible, right? And that's what makes it what's called a highly influential scientific assessment, because it hits all of those bars, and sort of like the gold standard. So that gold standard people then take and they say, okay, so this is what's being done here. I'm going to use this piece, or I'm going to use these set of models that were developed to help me with my transportation modeling here, right? That's the use of it. And what's happened over the last 25 years is that things used to be at this level, and now we're trying to come down to this level to be responsive to the fact that it's the on-the-ground information that is needed, and not the sort of maybe a little bit more pie in the sky. And that's why each assessment has a different flavor, right? Because we're getting a little bit better of responding to what we heard articulated in the last one. So if you heard, we still don't have enough information to do this, then the next assessment will try to meet that articulated need. So that's one piece, and that's why it's not prescriptive, because we're trying to see what we've learned, but also be responsive to what we didn't do so well last time. So then, I've literally seen folks take the assessment. It came out in November. By December, they're taking it and they're starting to do research to address some of those needs. Or they're taking it and they're saying, okay, let's get together all the state agencies who have a water focus, right? Because this is stuff that came out in the assessment, and it says, hey, we should be looking at this, this, and this, and we're not right now, so let's do that, right? So it helps to be like a signpost in that sense, to help with some of those local decisions, or even research like theses and dissertations.
That's great. Thank you for clarifying that, because it's being a federal piece, you kind of, I mean, certainly personally always wonder how it's being used. I've certainly anyways, I've always been aware of whenever it comes out, and always curious then where does it go from there, and anyways, the timescales related to that as well. So I was also curious along with Ed there. Thanks for that question, Ed. Mindful of everyone's time, your time as well, Lesley-Ann, I thought maybe just a couple more quick questions here. Maybe a little more weather, but also climate related. An anonymous attendee is asking if you have any thoughts about, say, the fires and the drought out west and their impacts perhaps out here in the Northeast. I know you sort of referenced a little bit about drought even in the Northeast, and even very timely, unfortunately, even here in the White Mountains, dealing with 2 separate wildfires occurring in this very brief but intense sort of dry fire weather period that looks honestly to return again just after
Yeah.
a quick, super downpour over the past couple days here. So I'm curious, generally, your sort of thoughts on those.
Yeah. So I think one thing that I always try to convey is that drought can occur anywhere. So it can occur in traditionally humid environments like the Northeast. And I think to the extent that we understand that that's part of our climate signal, and understand that, if we were having this talk, Brian, 50, 60 years ago, we would be only talking about drought, because the droughts of the early part of the 1900s was so prolonged and so severe. That's all that you saw, right? And then in about the 1970 timeframe, that regime shifted, and then it became more pluvial, more wet. And so now we talk a little bit more about flooding than droughts, but droughts are part of everybody's climate signal. And the truly unfortunate part is the extent, the severity, and duration of the drought that's taking place out in the West. And, with little to no end in sight. And the domino effect that has for all the economic structures, but the domino effect it also has for indigenous peoples. Indigenous peoples and water are very closely connected, and I think we don't appreciate that enough. And to the extent that we honor and lift up and cherish the way in which indigenous cultures are being threatened in so many ways by a lot of the water challenges that are taking place in the West is one dimension that I think is another piece that we don't always, like I said, lift up and understand. Wildfires, again, in the West, particularly large, particularly severe in terms of the burning. But you know as well as I do, Brian, that we also have wildfires here in the Northeast because the observatory undercasts for them, right? When we have those fires that are coming down from parts of the peat areas in southern Quebec, for example, you can literally see those smoke plumes. And so to the extent that we understand that wildfires are also a challenge and a hazard here in the Northeast, it may not look like it does in the West, but that does not make it any less critical to understand, because there's the human element, there's the air quality element, right? And so those are pieces that, that's why I said that we're the beginning system. We have to do it as a system, right? Because that way we're going to see what's that ecosystem in the Northeast from a hazard perspective. How does it interact with the ecosystem in the North, in the West? How do we get that intercontinental transport taking place? But how do all these patterns then play out? So system is what I would say to that question.
Certainly, yeah, certainly a connectivity there, and even from what you were answering even earlier about change in Arctic areas and the connections, regions that seem certainly far away. And I mean, I'll maybe just end with this question from Ken as well, who's thinking about perhaps another interconnectedness piece here of being, well, we think of large ice sheets that are over land, like say in Greenland. Well, there's certainly plenty of warming that's happening that far north as well, and significant melt. Ken's curious, well, isn't that going to cause sea level rise too? I mean, sure it's far away, but that'll be an impact that is likely experienced here and elsewhere globally.
Right. And then, I mean, we've seen a number of ice sheets and ice shelves that have been lost, that have been carved off in Antarctica, and the impact that those are having. And when you bring that together with the fact that a lot of these changes are occurring faster, at least the sea level and the sea, it changes just off the continental shelf here in the Northeast are occurring faster than in other parts of the US, then that's another cause for concern, another cause for adaptation, as well as mitigation.
Yeah, and on that very uneven New England coastline here, where I guess some areas okay, other areas certainly not, and we'll have to scramble to make some changes. So can understand how that's further complicates an already very complex issue. It's just sort of, well, perhaps uneven response, but also uneven response to uneven change that is occurring sort of throughout our region and certainly globally. Well, Lesley-Ann, thank you so much for joining us tonight. I really appreciate you taking some time out. I know it's the end of the semester here. It's almost graduation. You have to wear the professor hat in addition to all the other hats that you wear. So I really appreciate you giving your time this evening and sharing your expertise and for sharing your contact information and all that. I was able to share that out in the chat, I believe. Thank you everyone for attending this evening. If you enjoyed tonight's program, if you're a fan of the series here, I would encourage you to support programs like this in our organization over at mountwashington.org. You can always hit the donate button in the upper right-hand corner of the page there. And any donation, any amount does make you a member of the Mount Washington Observatory. So thank you very much. There is a survey that will follow up this program here and an email following up for folks who join via Zoom by tomorrow. So please share your thoughts on this program and any suggestions you have for future topics. We're always curious what you all would like to learn about as a service to all of you. And don't forget to join us for our next couple programs coming up in June and July here. Some Tuesday evenings coming up on June 21st and also July 12th. We'll be having speakers from the Gulf of Maine Research Institute. So fitting that we're talking a little bit about oceans there a little bit at the end. And then also in July, folks from the National Hurricane Center as well. So covering all aspects, weather and climate here for sure. Thank you again, Lesley-Ann. Appreciate you joining tonight. Thanks everyone else for joining and have a wonderful evening.
Thanks, Brian. It was a pleasure to be here, and thanks everybody for sticking with it.
Absolutely. It was worth it. At least I enjoyed it. Thanks, Lesley-Ann. Take care.
Oh, take care. Have a good night, everybody.
Take care. Bye-bye.